Next up, we have Aaron Schlesinger. Yes. Which has the hardest name to pronounce today, I'd say. Probably mine, but whatever. It's going to be talking about a very cool project at the Athens Project that is going to help us better manage dependencies in the Go community. So round of applause for Aaron. They removed my mic. Okay. I just realized that he had not plugged his stuff, so I need to talk more. So fun fact about Aaron is that he likes to run up mountains that have sugar names. So he likes to run up Sugarloaf, apparently, which I don't know where it is, but it sounds tasty. And also, he works for Microsoft, so he's wearing a 1Password t-shirt. I don't know exactly why, who paid whom, but it's interesting. Yeah. Okay, you ready? Yeah. Go. They will be on in. Yeah, go.
I'm not sponsored by 1Password, so don't worry. There we go. All right, who's ready for lunch? Yeah. All right, go ahead. See ya. Talk done. All right. Yeah, so I'm Aaron. I'm a core maintainer on the Athens Project. For those who don't know, this is all about dependency management, as Francesc said. So I'm here to talk to you all about how to make dependencies better in Go. So before we get into that, there's foundational technology we got to talk about here, and that is Go modules. So this is a new thing in 1.11. So who's heard of the Go modules system? Yeah, it's pretty good. Maybe a third. So for those who don't know, I'm going to just sum it up in a slide. So there's tons and tons of literature on it. There's tons to know about it. You can go to that short link and learn all about it. But for now, we're going to do a TLDR. This is pretty much all you need to know about modules. So we've got a new dependency algorithm called MVS, Minimal Version Selection. The two things there, the bottom two, are the awesome stuff for me. It's kind of the shallow things, but I'm a developer and I want to get stuff done. So I don't have to learn a new CLI. That's nice. It's all go get, go build, go install, and so forth. And then the shallowest one, which I love the most, is that there's no more Go path if you don't want. So you can put code anywhere on your machine. You can put it in the Go path too. That's totally fine. But you can put it anywhere else. And I'm actually going to demo live here, a demo that I haven't done yet, and cross your fingers for the Wi-Fi. And I'm going to show building an app outside of the Go path. Okay, so modules are awesome. I really believe modules are the future of Go dependency management. But we've still got this problem. When we do a Go get, we're still going directly to GitHub or whatever other VCS. And I'm going to just use GitHub as a placeholder for all of the VCS's version control systems that Go supports. All right, so when we do a Go get, we're still going directly to GitHub. We're still going to grab the code directly from a SHA or a tag in GitHub. So why is that a problem? Let's say you grab v0.1.0 from GitHub for, my cool package, github.com/my/cool/package, and you want 0.1.0. And that's cool. I'm the package maintainer, and you get to use my amazing package. You're welcome. And then later, a month later, I'm like, I don't really like that tag anymore. Delete, git push, delete tag, whatever. And then maybe there's a SHA that someone else is using. I don't really like that SHA anymore. I'm going to force push to it and delete all the code. Oh, I don't actually really like that whole repo anymore. I'm going to delete the repo. Okay, so either you vendored it and you're okay and now you're responsible for maintaining all that code, or you didn't vendor it and you are completely hosed. You're done, right? Hopefully someone else cached it and they'll give it to you out of the goodness of their heart. But if they didn't, you're done. Your builds are failing forever, okay? So that's a problem. Now there's good stuff about having people host their code on GitHub. Mainly we can federate, and that's amazing. More on that a little bit later. But there is this problem, and this is real. So most recently, the instance of this problem that sticks out in my mind is Go bin data. So for whatever reason, the original Go bin data repo was deleted. And we had about I think about 2 hours of chaos, and then someone else had a cached copy and put it up onto another repo on GitHub. So it was a fairly easy fix for folks. We basically just aliased from the old go bin data import path to the new one. But those 2 hours of chaos have happened before in the past. And as we scale, we add packages to the ecosystem and so forth, the problems will continue. They may get more, they may get less, but the problems will continue. But we've got a new solution now. Go modules comes with a download API. Now, this is obviously not a VCS-based API. This is an HTTP API. Now, this is brand new for Go 1.11. And this is an API that is specific to Go 1.11. It's not based on the GitHub API or the Bitbucket API or whatever else. Right? So we can build abstractions on top of this API that serve modules in a different way. And that's exactly what Athens is doing. We've got this new architecture now that we can build where we put a CDN or some other HTTP server that implements that API in front of the VCSs. So that's powerful because we've got this new big old gray circle, oval. We can do whatever we want behind that, right? It's a CDN. We can push out to the edge and really speed up downloads. We can keep that stuff in faster storage. We can keep that stuff in immutable storage. Remember that word immutable because it'll come up again. We can do a lot of things in there that the VCS, GitHub, whatever, may not necessarily have been able to do. And that's okay, because GitHub has a very specific use case, and that is to collaborate on code and make progress and do PRs and build communities and so forth. But it is not necessarily the best way to distribute modules or packages or dependencies. And that whole thing about git push-f and so forth, that is evidence. Those are manifestations of sort of the lack of support in GitHub for doing this dependency management. And this is how Athens does that whole CDN. Right? So you can see the VCS on the top there. The VCS is fronted by Athens and storage. Right? So Athens doesn't serve directly out of the VCS, although the VCS is the origin for code. So you still have the same workflow as a package maintainer. You git push, it goes into the VCS, but when someone else goes and uses your package and does a go get, and it's pointed to Athens, they're not getting your code directly out of Athens. So that frees you up as a package maintainer to be able to go do things like git push-f. Now, Athens will take care of that for you and your users by keeping your code in its storage immutably. So that means that if you publish v0.1.0 and someone does a go get on it, it's in storage. It's in that little database, whatever that thing is, column, whatever, that's got the little circle on the top and the big column down there. Right? The pink thing, that's that color. Anyway, it's stored in there forever. So if you go and delete v0.1.0, it's not deleted from storage. It's not deleted from storage. That's important to remember because it's a best practice. Athens is saying it's a best practice to not go and overwrite code that you've already pushed. And if you do, it's going to diverge from what Athens had in its own storage. So kind of to sum up in 4 bullet points, what Athens actually is that it is that HTTP download protocol. And there is a CDN in front of it to push modules out to the edge, closer to you. And I mentioned the immutable storage, and there is an asterisk there. And the reason we need that is for things like DMCA takedowns and major security vulnerabilities and so forth. But those are kind of the 0.01% cases. In many, many, almost all cases, code will be immutable in there, and you can rely on that code to be immutable in there. So no more folks accidentally deleting repos, no more git push-f problems, no more 2 hours of chaos. If you're familiar with the Node.js world, no more left pads being deleted and breaking every single line of Node.js code in the world. Anyone remember that? Yeah. There was a Business Insider article on that. I actually thought about putting that article in the slides and making people read it, but it didn't do that, right? So that immutable storage piece is very important to Athens. And then the bottom two bullet points are also very important. So we're not trying here to be a central registry. We're not trying to be like the end-all, be-all database for modules out there in the Go community. We're trying to present an API in front of the VCS, in front of GitHub, whatever else. We're trying to store that code in stable, immutable storage so that folks can get at the code with some more guarantees. But we're also trying to make it really easy for anybody to run Athens, whether it's publicly or privately inside of their organization. And we're also especially making it really easy for anyone to run a public mirror, and more on that a little bit later. That's what the federated point is all about. And I'm stressing it now, and I'm really gonna go back to this and circle back on the federation point, because it's actually very important, not necessarily for the technology, but more for the community here. All right, so we're gonna start with some puns. We're gonna do a live demo here. We're gonna see if this microphone's gonna work. Is it working? How do I get this mic to work? Yeah? All right. All right. So I have sort of this demo script. I'm going to be leaning over like this very awkwardly so everyone can hear what I'm doing. All right, so kind of to prove that we're not doing VCS interaction, because that's very important to the whole sort of value proposition of Athens, I'm going to start up a VM. So I don't want people to have to wait and watch my actual Ubuntu VM starting up. So I'm going to kind of hack this and open up a Docker container. But I'm not mounting anything into the Docker container except for a checked out version of Hugo. So who's familiar with Hugo? Okay. So for those who aren't, Hugo is a static site generator, right? It's a fairly simple concept, right? You take a bunch of Go templates and you organize them, and then you run Hugo against them, and it builds a bunch of HTML for you. You can push the HTML up to S3 or Google Cloud Storage or Azure Blob Storage, which if you do, then my paychecks will keep clearing, so please do that, right? You can push it up anywhere, any static site hosting system. We use it to host the Athens documentation, in fact. So the reason I'm telling you all this is because this is a real project, right? This isn't something that I just made up. It's a real project. I have the source code right here. Can anyone not see this? Okay, cool. So this is a real project, and you'll notice it does not have a vendor directory, and it does have a go.mod file, and these are the dependencies that Hugo relies on. Close this down here, right? So these are sort of what we call the top-level dependencies. These are the things that Hugo imports. All right, so there's quite a few there. There's a couple excludes here. There's some aliasing, right? So this is Go modules. This is 1.11 Go modules. For those who are wondering, there's also basically a lock file with some hashes as well to do some security and validation stuff. Right, so this has nothing to do with Athens, but it's foundational to how Athens works. Okay, so let's get into it. I'm gonna go in here. Let's see. So I'm mounting Hugo into the Docker container. Can anybody not see this? Awesome. All right, so let's check out the Go path. Okay, that's in /go. We are not in the Go path. So let me stress that. We are not in the Go path. Ladies and gentlemen, we're not in the Go path. Okay, then the second thing here is we're going to remove Git. So if I go back to the go.mod, almost all this stuff is GitHub. So in theory, we would need Git to download code from GitHub. So there's Git. Ladies and gentlemen, there's Git. We're going to get rid of Git. Okay, so no more Git. You can probably see where this is going. Now we're going to set this environment variable called GoProxy. This environment variable tells Go modules to talk to this server, which is on the public internet and can be used by anyone. There's no auth, there's nothing else like that was going to prevent you guys from using it. I would recommend you don't use it for production, because it's experimental and it might go away anytime if I accidentally push something that's broken or accidentally delete the account behind it. But we're going to use it today. And also, some of my projects, personal projects, use it as well. Okay, so now Go modules is going to only talk to this server to get dependencies. It's never going to try to do Git clones. It's never going to try to get stuff from Mercurial. Is that how you pronounce it? Yep. Okay, Mercurial. It's never going to try to get stuff from some internal VCS system that I might be running. It's literally only going to talk to that server, and it's literally only going to be using the download API that I showed in a couple slides ago. Another point to mention here is that there's nothing that's faster than a local cache, right? So we've got this sort of cache, sort of like you can think of this as a vendor directory on the network, that's Athens. But Go modules also keeps a cache locally. And that cache is under the Go path, under PKG, under the mod directory. So we've got no local cache. That's sort of to prove that we're actually going to download stuff from the network. And now we're getting to the part that's literally the most boring demo ever. This is it. I'm going to clear the screen and show what goes down here. Uh-oh. There we go. Okay, so there's some new output that we haven't seen before, right? When you did a Go build on 1.10, these output lines didn't come up. So let's look at what's going on. So up here, this is the Go module system going into the go.sum file and figuring out, hey, where are these modules? Namely, are they in my local cache? Remember how the local cache didn't have anything in it? So it moves on, and it says, all right, well, we got to find that stuff somewhere. So since there's no Git, obviously, and since we've got our Go proxy environment variable set, it knows, okay, I've got to go and download code from the server that's set in Go proxy, and I've got to use the download protocol. That's just a bunch of HTTP GET requests. All right, so cross your fingers for the Wi-Fi. We still got some stuff to do here. Come on. This is networking over Docker network. Almost done. Almost done. Come on, come on. So at this point, all the modules are downloaded, and this is basically the last step to see if Inflect, which was already downloaded, is actually in the cache. Okay. So there should be a Hugo binary installed. Okay, we've got that done. So just to recap, we built this thing without getting any stuff from the VCS, and we got it all from the Athens server. So that is a live Athens server that's got a database behind it. It's running Cosmos DB, which is also an Azure product. You guys are free to use that as well. So it's running that, right? It's got stuff stored in there, and it's got a little CDN in front of it. So the downloads, although the Wi-Fi wasn't great here, the downloads were actually happening from a CDN that's relatively close to here. And that's what all these downloading package names were doing. It was going to the CDN and grabbing that stuff. Okay, the other point here, let's go back to our local cache. And this local cache should be full now. I'm going to clear the screen here. And now we've got the local cache filled. So let's check out what's in GitHub. Okay, this is starting to look a little bit like our Go path used to look like. Okay, so let's go and check out like Gorilla. Okay, so we've got WebSocket, Gorilla WebSockets. We've got an @ version number. And this corresponds to the version number that was in the go.sum file. Okay. What happened here? Thank you. Okay, so there's the code for WebSocket. So the code came from somewhere. We know it didn't come from Git. So let's look at where the code actually did come from. And there's kind of two big things here to point out with regard to where the code came from. Now, the first thing is, since we're not getting stuff from GitHub, since we're not going to be dealing with that git push -f problem, we're not dealing with the dude. We're not dealing with the dude anymore. So there's no sort of thing where at 10 a.m. I come into work and I do a go get, and then Joe developer, my colleague, comes in at 11 a.m., does the same go get, and the repo's gone. Right? Athens and that URL, it keeps the code forever. That's the immutable storage. Okay. Now the second thing is we are only downloading zip files of code. We're not downloading Git trees anymore. Okay? There's no Git history, there's no tags, it's only the code at the specific tag or the specific SHA. So these are some of the big-ish repos out there, and look at the difference. It's 20 to 30x smaller, right? And that zip file is the thing that Athens is serving, not the Git, okay? Now, if you go to some smaller repos, obviously the spread is not as big. But when you've got a vendor directory that's, let's say, 100 megs, it makes a big difference. Even 100 megs, it makes a big difference whether you're downloading from a CDN with just the code and not the Git tree, or you're downloading 830 megs versus 39 megs from a CDN. All right, so that kind of covered why this is a little faster, and that kind of covered why you could have a vendor directory, and that's okay still. There's nothing stopping you. But you could also kind of relegate the vendor directory to an Athens server, whether that's an internal Athens server, which we'll get to in one slide, or whether that's an Athens server running a CDN on the public internet. Okay, so that internal Athens server, can I take this mic off now? Yeah, okay. All right, cool. So the Athens server itself is being run inside firewalls. Okay, so we've got folks who are actually doing this, and they're serving code, their private code in their private VCS, GitHub Enterprise or whatever else, or GitLab, and they're serving it as modules internally. So they might be in the cloud, and they might be running a private CDN, or they might just be running it on someone's laptop. It doesn't really matter. So essentially, they're insulating it. This is kind of like running your own Artifactory, but for Go. And Athens can also talk upstream to a public Athens server, or if you have an exception in your firewall, to GitHub or another VCS publicly, the public code on GitHub. And Athens allows you, of course, to have include and exclude lists so that you can say as an admin or the CTO or whatever, hey, this version of this package has a security vulnerability or licensing issues, so you can't use it. Athens will block that from being downloaded. And we actually have a couple use cases where someone wants to demo Athens in China. And so what we can do is we can set up a database. We can pre-seed an Athens database, ship it over on a USB key, and install that database behind an Athens for demo purposes or for someone to run inside of an organization there. I wouldn't recommend doing that. Please don't do that. But it's possible. And the other one here, this goes back to the federated point that I made sort of at the beginning. We've made a lot of effort to make Athens easy to run and document it so that it actually is possible to run it in a fairly short period of time. And the reason for that is we don't want to be the only service running. We don't want that public Athens at the Go proxy URL that I showed to be the only Athens. We want public mirrors. We don't want to have to make sure that, we're being relied on by a million Go developers. Right? We want people to have the freedom to run their own, to have their own include and exclude lists, to have their own code. If they want to update code on their mirror, to be able to do that. Right? And the reason this federation is possible is because of that download protocol. Essentially, this thing is the lingua franca for any Go module that wants to be downloaded on the public or private internet. The private internet is not a thing, I just realized. Inside of a firewall, we should probably say, right? So not only can Athens servers talk to VCSs via the Git protocol or whatever other protocol, they can talk to each other via the Go module HTTP download protocol. And even more than that, you don't have to run Athens in order to participate in this ecosystem of the Go module download protocol mirror servers. You can write your own. If you look, there's documentation on the Athens docs, there's documentation on the Go wiki, I wrote a blog post with the download protocol in it. It's actually not that hard to implement. Build it in, I don't even know if it's possible, but if you figure out a way to build a REST API in Bash, you can build an Athens server. Is that possible? Anybody? Yeah? Can you build an Athens or a Go module server for me? That'd be amazing. But anyway, use any language. Recommend using Go, obviously. It's what Athens is built in. We're all Gophers. But you can do it any way you want. And you can still participate. And Athens can talk to you. You can talk to an Athens. You can talk to someone else's. It doesn't matter because everything speaks the Go module download protocol. And I really can't stress that enough because I believe if there are a lot of different servers out there, whether they're Athens or not, we have a stronger ecosystem. Okay, so just to sum up and kind of finish this thing up so we can all go to lunch, this is kind of where we are. So we've got organizations starting to run this thing internally. So I got permission from one of the Athens core contributors to say that one of their teams is using Athens sort of in a testing phase, and they've got a bunch of other teams that are starting to test, I think, in a couple weeks. So this stuff is not in production there, but you see the second point there, we're getting to a beta. We've got just a few things left to get to a beta, and once that happens, we're gonna get more pickup. There are 3 other orgs that I couldn't get permission to name that are also starting to test this thing internally. So this is just over 6 months old, so we're getting a little bit of traction there. I wouldn't expect it to be in production publicly until probably another 4 to 5 months. But we are experimenting now with a public proxy, and we've got an issue open for a non-experimental public proxy to start giving folks in the community a little bit more guarantees to start testing this thing out, maybe in staging. And we'll be making a more wide announcement on what that really means and when that's really going to happen on the Athens blog and some other mediums as well. Ironically, the Athens blog is on medium.com. So we'll be publishing on Medium and other mediums. Okay, so last slide. This is kind of how to get started. We're a super welcoming community. That's kind of our main feature besides the download protocol. So drop in, talk to us in an issue in the GitHub repo. Drop into the Athens channel on the Gopher Slack. Come talk to me, DM me on the Gopher Slack, DM me on Twitter, my DMs are open. Come talk to me back there after the talk. You can go check out the demo repo. There's a demo repo that has that script that I ran. Go to that short link. really, we're open. We're a young project. We're open for contributions. And we would love to have you, whether you want to say, I loved Aaron's talk, which of course you all did. You want to say, I've got a question, whether you want to contribute. You can contribute docs. You can contribute on a thread and an issue. You can contribute code. We've got a lot to do. Right? We're just a very welcoming community. We would literally love to have all of you just drop in and say hi. So that's all for me today. I would love to take questions in the back. Understood if you want to go eat lunch. I do. So you can talk to me after lunch, after the talks, after lunch, during a break. And I really just want to thank everyone for coming out and talking about Athens with me. So, take care, guys.